The demand for energy has been constantly increasing due to a rise in population. The International Energy Agency has predicted that in 30 years, the population of developing countries will continue to rise, whereas the population in developed countries will plateau. Non-renewable resources are limited and will run out. Renewable sources such as solar are not efficient, and there is little research to make these better. Nuclear energy is the best compromise because it has a high energy density and is very efficient. We believe nuclear energy can solve the energy crisis.
So, how do they work? Nuclear power plants operate in a similar way to conventional fossil fuel combustion plants, converting heat to electrical power using steam. The difference here is that heat is obtained from nuclear fission.
Nuclear fission is essentially splitting up of large unstable atoms, usually uranium, by firing neutrons at them. The uranium atom, acquiring extra energy by absorbing the neutrons, vibrate and split into smaller atoms and 2 to 3 neutrons. If you measure the mass of the initial atom and the total mass of the product after the split, some mass seems to be lost. Einstein's famous equation E equals mc² tells us this incredibly small amount of lost mass is converted into a huge amount of heat energy. It's really exciting when we put a bunch of uranium atoms together. As one atom splits up, it releases more energetic neutrons, ready to split up some more atoms, which in turn releases more energetic neutrons, and on and on. This is known as chain reaction. But if we don't control this reaction, we'll soon end up with a huge amount of heat energy, resulting in a nuclear meltdown. So control rods are low as necessary to absorb neutrons, stopping them from splitting other atoms. With this and other design features, nuclear reaction can be regulated to produce constant powers.
Most common reactors are pressurized water or boiling water reactors, accounting for over 83% of all nuclear reactors. The boiling water reactor instantly boils the coolant, in this case water, directly inside the reactor. The pressurized water reactor pressurizes the coolant, which vaporizes a secondary stream of unpressurized water. The second method keeps contaminated fluids separate from process equipment, giving the plant a longer life and safer operation.
After events such as Chernobyl disaster and the Fukushima incident, the emphasis on nuclear safety is greater than ever. Therefore, safety systems have been implemented, such as the passive cooling containment systems and the passive decay removal systems, both which aid in the removal of excess heat to prevent the overheating of the reactor. Other systems, such as the passive safety injection mechanism, help alleviate pressure by condensing steam. In order to prevent the exposure of radioactive substances, the transport of materials such as the radio waste, plutonium and nuclear fuel have to be handled carefully. These can be categorised as low-level, intermediate and high-level waste.
Commercial power station being constructed in the 1950s. There are currently 435 active nuclear power reactors located in 31 countries. As shown, the country with the most plants is the US, with a total of 61 commercially operating nuclear power plants. When looking at the viability of nuclear power, costings and construction times have to be taken into consideration. An example can be taken from the Atucha 2 reactor located in Argentina, which took a staggering 33 years to build. Although in extreme case, many delays can occur in the construction by factors such as public opposition, engineering failure, governmental crisis and environmental factors. These plants do not come cheap either, with the power and light plants in Florida costing a whopping $17.8 billion for two 1,100 megawatt plants.
Nuclear energy, powering the world in a greener way.